Okay, in today's lecture, we will see both multiplication method. Okay, so today's lecture content are both multiplier introduction. First, we will see the introduction of the both multiplier. Next, after that, we will see both flowchart, and in last, we will discuss on both examples. Okay, so let's see the introduction. Why both multiplier algorithm? Both multiplier algorithm is used to multiply both signed and unsigned integers in binary by using 2's complement. Okay, both multiplier algorithm use less number of addition and subtraction to solve a problem. When we perform subtraction operation, then both multiplier algorithm use the 2's complement method for subtraction operation. If strings of q and q minus 1 is equal to zeros, okay, you can say pair of zeros, then only just right shifting one bit method is applied here. Okay, if strings of ones and zeros are in the following form, suppose a q minus 1 is equal to 0 1, then you have to apply addition operation and change the value of accumulator to a plus m. Okay, and then apply the right shift operation. If q minus 1 is 1 0, then you have to subtract. Okay, change the value of accumulator a to a minus 1 and take the right shift. If suppose q into q minus 1 is not 1 1, then you have to apply right shift operation. Okay, next, this algorithm multiplies two signed binary numbers into complement notation. Requires examination of multiplier bits and shifting of the partial product. Suppose if large number of blocks in the consecutive ones and zeros in the multiplier, then it is the best case. When best case occurs, when there is large number of means you can say number of pairs of ones or zeros, suppose 1 1 and zeros, then there is no need to addition and subtraction, you just simply right shift one bit. Okay, so it takes the less number of operation. Okay, then we can say this is the best case for the both multiplier algorithm. If suppose there is no bit pair in the form of 1 1 and 0 0, then we have to apply addition and subtraction method. That takes long time to solve in addition and subtraction, so we can say this is the worst case for the both multiplier algorithm. Clear? Now for the flow chart we have to remember some terms. Let m equal to multiplicand, suppose m is the multiplicand and q is the multiplier, and let q minus 1 is the 1 bit register and q minus 1 suppose initialize with 0, and a is the another register which is also initialized with 0. Okay, in initial conditions. Let n is the total number of steps, or you can say count, total number of counts, where n is the total number of bits used in the binary multiplier q. Okay, this is the flow chart in the booth algorithm. So first we have to start. These are the some terms that we have considered. Suppose a is the accumulator or register which is initialized with the 0, and q is the another register, 1 bit register also initialized with 0, and m is the multiplicand, suppose 6, and q is the multiplier, suppose 2, and count is the number of steps, that is n. Okay, if this shows the diagonal symbol shows the condition, if q naught and q minus 1 is equal to 0 1. Okay, if the bit pair here is 0 1, then we have to apply the operation a equal to a plus m. Okay, and then take the arithmetic right shift. Okay, we shift the values or 1 bit change in a, q and q minus 1, and decrease the step from n minus 1. Okay, if and then check the count 0, if count 0, if no, then again go to the condition, check again. Now what are the values of q naught and q minus 1? Okay, if suppose here bit pair is 1 0, and if bit pair is 1 0, then we have to apply subtraction method, then change the value of a equal to a minus 1, and then take the arithmetic right shift. Okay, and then decrease the step, and then again check the count value, if count value equal to 0, if no, then again go to the previous step, and then check the value of bit pair. If suppose now the bit pair value is 1 1 or suppose 0 0, then we have to directly arithmetic right shift. Okay, no need of addition and subtraction, just only shift 1 bit right. Okay, and then decrease the value of count by 1, and then check, if suppose count value is 0, then if suppose yes, then we have to stop here. Okay, this is the flow chart of the booth algorithm. Clear? You just remember here we have to start with a equal to 0, q minus 1 equal to 0, and multiplicand value convert multiplicand in binary form, and q multiplier in binary form. Okay, and then check the value of q naught and q minus 1, and try to solve as per the bit pair. Okay, This is the flow chart. Now we have to move on next slide. So this is the example. Here we are considering m equal to 6, means multiplicand value is 6, and the binary integer is 0110 of number 6, and q is the multiplier here, which is 2, and the binary integer is 0010. So you can say q naught, q1, q2, q3. Okay, q naught value is 0, q1 is 1, q2 is 0, q3 is 0. Okay, so make this table. First you have to write here initialize, then a, then q minus 1, and what are the operation you have to apply, or what you want to apply. Okay, so initially the value of a is, we are putting here 00, and for q value is here 00 and 10, and initially we have put q minus 1 is 0, and m dash complement, first complement. Okay, and this is this 2's complement of the m, that is 1010, and subtraction is a minus 1, a minus m is equal to a plus m dash plus 1. Okay, so step 4, because total number of digits here is 4. Okay, so we have to start from step number 4. Now check the value of q and q minus 1. So here q is most significant bit is 0, and here is 0, so no need to addition and subtraction. Directly we have to perform arithmetic right shift. Okay, just one bit shift. Okay, this 0 goes here, 0, then 1 here, then 0, then 0, then this 0 goes here, 0 0 0, then we have to put 0. Okay, now check again q and q minus 1. Okay, here q is 1 and q minus 1 is 0. Okay, we have to perform 10 bit pair operation. Okay, 10 bit pair operation. So 10 means we have to subtraction operation, so equal to a minus 1. So when we apply a minus 1 method, then this gives the 1010. Okay, you can check with the help of this method. Okay, here a is this value. Okay, 4 times 0, and minus m. Okay, m is stand for this 0110. So when we perform a minus m, we directly uh, perform the addition operation. Just write the a, then find the ones complement of a, and then add 1. Okay, this gives the this result. Clear? This one. Then we have to put this one as it is, and q minus 1 value is as it is. Then again we have to perform arithmetic right shift. Then put this 1 here, one bit shift, right shift, 0 here, 0 here, 0 here, and this 0 here, 1 here, 1 here, 1 here, and in last is 1. Okay, this is the arithmetic right shift. Now we have to perform next step, and then check the value of count. Okay, so count value not equal to 0, so we have to perform next step. Next step is 2. So here q and q minus 1 value is 0 1, you can see here. Okay, 0 and 1. Then we have to perform a addition operation. Then this is the value of a plus m, then sorry, this one is the value of a plus m. Then we have to take the arithmetic right 1 bit right shift. Okay, then this 0 goes here, 0 0 0, and this one here, 1 0 0 and 0. Okay, again check the value of q and q minus 1. Here in the last you can see 0 and 0, so no need to addition and subtraction, directly apply the arithmetic right shift 1 bit right shift. Okay, just take this one 0 0 0 1, then this one, then 0 0 0 and 0. Okay, so next we have to check check the value of count. So now count value is 0. Okay, so we have to stop here our operation, and this is the final answer. Okay, in binary we have to write 12 1 1 0. Okay, so the final answer is 12 of 6 into 2. Clear? Okay, thank you.